Hello everyone, welcome once again to another lesson in this Python Machine Learning Fundamentals series, whereby we're taking a look at another toolset today known as NumPy. So what is NumPy? NumPy stands for Numerical Python. It gives you the necessary tools to handle large amounts of data efficiently, which is exactly what we need in machine learning where performance matters. So how do we begin to use NumPy or import NumPy? We use the following command where we import NumPy as np, meaning it is a common shorthand where we can use NumPy by simply writing the np dot and using all of its methods. So for example, we have a NumPy array. What is a NumPy array? Remember that an array is essentially a list. So a NumPy array is like a Python list, but better. NumPy arrays look like Python lists, but they are faster and more powerful. You can add, multiply, reshape, and process them with simple syntax, and they use less memory also. So creating an array in NumPy looks something like this. So we created a variable, called it ARR, equals np, so NumPy dot array, and then we've got this simple array here. So to create a basic array, just use np.array followed by brackets and pass in a list. From here you can do powerful math with just a few lines of code. And here's some different methods of things that we can do with our lists. So for example, if we want to create an array of a 2x3 row or array of zeros. Oh my goodness. So here's a list of common things that we can do with our array. If we want to create a 2x3 list array of zeros, we do np.zeros 2x3, and of course we can change these numbers to whatever we wish. If we want to create an array of simply ones, so here we pass the number 5, so we'd have a list of 5 ones, for example. If we want to do np.arrange, then we can create a list of I need to do this one again. So here are some common things that we can do in order to manipulate our arrays. So some common methods which we can apply to NumPy. So we have numpy.zeros. This simply creates a 2x3 array of zeros, and we can change this number here as we wish. We have next numpy.ones, so this simply creates an array of ones, and once again we can change this number to whatever we wish, whether that is 5 ones or we want 10, a list of 10 ones, etc, etc. Next we have numpy.arrange, and so this will create a list within a range, and these numbers here will represent how our list is outputted. So for example, just remember the 3 S's: start, stop, and step. So we have where we want the list to stop, knowing that, bear in mind, this number will be excluded. So we want the list to start at 0. You can see our list starts at 0 here. Our list is going to stop at, well, our list is not going to make it to 10 essentially. So the last number on the list is going to be 8, and it's 8 because we're going up in multiples of 2, in other words, the step. So once again, we're starting at 0, right? We're going up in 2s, 0, 2, 4, 6, 8, and we're stopping before we hit this number here, 10. So that means the last number in this list will be 8 as we're going up in 2s. Another common array type or method we have is line space, where we have 5 evenly spaced values from 0 to 1. Alright. So NumPy gives you shortcut functions to create arrays filled with zeros, ones, sequences, or even spaced values, and these are perfect for testing or initializing models, and we're going to take a look at some of these in our practice time. So every array has a shape, size, and a number of dimensions. So these properties help you understand and control how the data is structured. So we're going to take a look at these also. Next, we have indexing and slicing, which of course we would expect, having looked at some of these techniques in our previous lessons where we looked at lists and tuples. So you can access or index and slice arrays just like lists. This lets you pull out exactly the data you need, whether it's a single value or a sub array. So again, we have this variable here called array equals np.array, and we've got this simple array here of 4 different values. So we wanted to print the array at index number 1, and this will output 20, 10 is index 0, 20 is index 1, and we have print array 1 to 3. So this is known as a slicing method, and it's similar if we look at our previous version where it doesn't include the third index number but instead leaves it out. So instead of expecting to see 40 here, this is why we're getting 30. So we are slicing this list. Reshaping arrays. You can reshape arrays into different dimensions. So this is critical machine learning where you often need to organize data into rows or columns for the means of training. So when we say dimensions, we have a 1D or one-dimensional array here, which is just simply one list, or we can have, for example, a 2D array where we have 2 separate lists or 2 dimensions to our list. So these could represent, for example, the x-axis and y-axis, for example. NumPy also lets you apply math to entire arrays at once. No loops needed. We can multiply, divide, add, subtract, and instantly across all the different elements. So as you can see here, we have this list here, which we have stored in this variable called ARR. So what we've done is we've printed ARR, and we're going to times 2 to this entire list. And as you can see, the 1 becomes 2, the 2 becomes 4, the 3 becomes 6. Or we can add 1 to every number in the list, as we've done here. The 1 becomes 2, 2 becomes 3, 3 becomes 4. Simple as that. So we have many different methods when working with arrays. Here are just a few where we want to find the minimum and the maximum values, where we want to calculate standard deviation or calculate the mean of a list. Yep, we have many different methods which we can apply to our arrays using NumPy. NumPy handles 2D arrays or matrices also easily. This is crucial in machine learning where data is often stored in rows and columns, just like in spreadsheets. And don't worry, all of these we are going to take a look at. Next, we have something known as broadcasting. So this is very simple and similar to applying math to our lists. So we've created a basic array here, and we want to apply a simple operation to this list once again. So we want to say plus 10, and so this would be the result, adding 10 to every number in the array. This is known as broadcasting. Next, we also have something known as Boolean indexing. So we can filter arrays using certain conditions, right? So this is called Boolean indexing. It's a fast, elegant way to clean or extract data that meet specific rules or criteria. So once again, we've got a basic list here stored in a variable called r. And so we're taking this r variable or this list, and we're saying within this list, fetch me back all the numbers that are greater than 25, that meet this criteria, that they are greater than 25 within this list. And so we have 2 values, 30 and 40. Perfect. Next, we have some random operations that we can perform, especially useful when it comes to testing. So we've got np.random.rand, and so this will automatically bring about a float number, and so indicating that because we have the number 3 here, we're going to get 3 random float numbers, usually between 0 and 1. Alright, so we could have 0.65, we could have 0.04, we can have 0.7, for example, 0.89. Alright, and this is very good for when we're trying to work with percentages. Okay, 1 being 100%, 0 being 0, 0.5 being 50%. Okay, and so there's many different random methods which we can use. We can use np.random random integer, for example, and this will generate a random integer between 1 and 10, for example. Okay? So before we get into our practice, let's go over a quick recap. So NumPy is used for fast numerical computing. We have what is known as arrays or lists, and they replace classical lists for machine learning, as it's much easier to work with lists using NumPy. It allows for easy math, reshaping, and many different types of statistics. It also supports things such as filtering, broadcasting, and much more.